Hi there, today on the bench a display module Elecrow sent me for review. I did not pay for it, so I mark it as a promotion, but as you know, that doesn't stop me from giving you an unbiased review. This is an e-paper display, so last image remains even without power, and this is how it arrived. The module has no battery. On the left side we have a gap which basically exposes the ESP32 Bluetooth and Wi-Fi antennas, a tiny socket for a battery and a USB-C connector. The bottom side has an SD card slot. The right side has two push buttons and a three-way jog dial in the middle. The jog dial can be pushed left, right and down. The other two buttons are just for pushing down. On the underside you see a GPIO socket and the first of two holes with metal threaded inserts to mount the whole module. The thread fits M2.5 machine screws. You may be able to see that there are rather faint engravings with labels of the buttons and sockets you saw earlier. And two further push buttons, one is labeled boot and the other reset. Finally, there's a hole with a red LED underneath. Applying USB-C power and the module comes to life and runs a demo program. The flickering at the beginning is unavoidable when initializing the display. I paused the video here for a moment because this shows essentially the parameters, size and resolution of the black and white only display and the processor, flash and RAM. Then the demo proceeds to reinitialize the display again and shows the menu we saw earlier. The difference is that now the processor is running, so we can select and run these items. But this is no touchscreen, so I have to use the jog dial. Well, you can read the blurb. Pause if you need to. I just wish they would not reverse background and foreground all the time. I find that rather irritating. The exit button brings me back to the main menu after the usual flicker. Let me try the image menu next. This cycles through several images rendered on the display. The resolution is what you would expect from a black and white 400 by 300 pixel display. And back to the main menu. The last thing to try is scenario. This is apparently a mock-up of a controller for remote adjustable lights in a house. Well, the user interface and especially the constant background-foreground reversing is certainly not everyone's taste, but I get what they're trying to do, and I'm sure a more appealing software can be written. This brings me to Elecrow itself. I must admit I'd never heard of the company before, but they seem to cover just about everything an IoT maker would need to put together hardware, displays, sensors and all kind of I/O peripherals and then write software to make it all do something cool. Just a quick scroll through the wiki here to whet your appetite. Plenty of Arduino, shields of all sorts. CrowBits is a modular education system of little boxes that can be connected to each other and a motherboard running sketches. Sensor boards, very much like Adafruit for example. Wireless I/O modules, and of course lots and lots of display modules. Finally, they also do PCBs and such. As my display arrived with zero other information, the first port of call is the Elecrow Wiki for it. Scrolling through there, you find more detailed specs and an image of the board underneath the display, which is basically an ESP32 development board. It tells you about the different periphery items, buttons and so on, and how they are mapped to what I/O pins. The only integrated development environment or IDE supported for this board is Arduino. There's a GitHub link and schematics, and the PCB layout can be downloaded. Nice. Finally, there are links to zip files with Arduino code for demos and examples. A pretty comprehensive wiki entry in my opinion. I decided to give the weather demo a try, as this was an application that I consider a good fit for an e-paper display with information changing not too often. The documentation walks you through the steps and explains the code. The demo uses a couple of images, and the first thing to do is convert these bitmaps into C code arrays. And here's the first hurdle. Although so far everything is English, the tool needed for the conversion is not. The same is true for comments in the display driver C code if you drill down that far. Regarding these hurdles, Elecrow simply suggests to use Google Translate. The demo uses the OpenWeather API to get the weather for a specific lat long, so you need to modify the code to allow the module to access your Wi-Fi and provide a valid API key for your own subscription to OpenWeather. I'm okay with the first, but not with the second. As I looked into OpenWeather, there is a free subscription, but my understanding is that even for that they want payment information in case you exceed the limits of the free subscription, for example by calling it too often. Instead, I went for a free subscription to the UK Met Office app that also has limits, but if you exceed them they simply throw an error back. No payment info is needed for the free subscription. It turns out that while the Met Office API delivers JSON like OpenWeather, the content is quite different. Besides, the demo shows basically the current weather at a location. If it's your own location, you can see that by looking out of the window. I'm more interested in displaying the forecast data, which requires a major rework of the UI and code. With no time for doing this for this video, I disabled the API call to OpenWeather and preset the variables that would normally be populated from JSON. To be able to compile, I need to enable ESP32 boards in the standard Arduino IDE and also enable JSON extensions. There are a few other things that I explained here. Although compiling worked, downloading did not. I contacted Elecrow support and they came back pretty fast explaining that the board needs to be prepared for that. One has to press boot, keep it pressed while hitting reset and then release reset before releasing boot. Maybe that is a standard thing for Arduino or ESP32, but I'm usually working with Raspberry Pis, so I did not know the magic sequence. Well, with that help everything worked. I played around with different presets just for fun. Apologies to all Londoners for messing with their weather. One thing to mention, the guide says some info is shown on the display while it downloads. That is not the case. Here I am downloading a new version, but the display shows whatever was showing last until the processor resets at the end of the download. I measured the current draw on the USB-C after the display was updated and it was disappointingly high, more than 30 milliamps, as I remember, because somehow I lost the video of that. The demo code has just this delay statement to sleep for 1 hour between updates. While delay reduces power, it does not turn everything off. A quick dive into the ESP documentation uncovered the deep sleep capability, so I gave that a try. I outcommented the delay statement and added the highlighted code. There's some extra here that I needed for debugging, which you can ignore. Basically, the processor is prepared for deep sleep by setting the wake up timer first. To speed up testing, I set it for 60 seconds, not 60 minutes. After the weather is displayed, the deep sleep is started. Here it is in action. Well, I mean sleeping. The deep sleep current is now only 6.3 milliamps. When the wake-up timer expires, the processor basically resets. Unfortunately, this means the display is flickering while it's reinitialized and the Wi-Fi has to be set up again. Here's the recording from this run. If the timer is 60 minutes instead of 60 seconds, I think the drawbacks of a processor reset every hour are worth the saved energy. And maybe there are more tricks that can be used to save a bit more. I've just started to look. Although we already saw an image of the PCB on the Elecrow website, let's have a closer look. 4 screws into threaded inserts are holding the backplate. Actually, these are the same inserts as the one for mounting, so nothing stops you from using these to mount the panel. Okay, the backplate can be removed. With about 2 mm thickness, the backplate is already quite substantial. Yet Elecrow have added a 4 mm insert that fills all voids, creating a sandwich that provides superb protection and mechanical stability. This is beautifully made, hats off. No surprise, the PCB is exactly as shown on the web. For me, the most interesting thing at the moment is the BAT connector on the right. Here is a section of the schematic downloaded from the Elecrow website. There is a proper lithium-ion battery charging chip in form of U6 4054A. With a 2K resistor on the proc pin, the chip should charge at 500 milliamps. On the web-based spec sheet I showed earlier, the battery connector is listed as an SH1.0 2-pin. I don't have one of those, but I ordered one. I think there will be a part 2 when I connect the battery and change the software to use the UK Met Office API. Until then, I want to thank Elecrow for sending it in, and if you are into IoT or just need a display or sensors, I definitely recommend looking at their website, elecrow.com. If you like my videos, don't forget to like and subscribe, and maybe consider becoming a Patreon. That would really help the channel. The link's in the description. Thanks for watching and clear skies, everyone.